हम लोग बात कर रहे हैं सीरीज ऑफ रियल नंबर्स की. We have already talked about sequence of real numbers. What is that? Today we will talk about what is series of real numbers. So let's start with the definition. If an in curly bracket, this is representing the sequence of real numbers, then if you add all the members of the sequence, how many members? Infinite sum of the members of sequence is defined as the series, and it is represented by like this, where n represents the term, and what is the value of n? Value of n starts by n and it goes till infinite, means infinite sum of values of any sequence. It gives us a series of real numbers. Now what is sequence of partial sums? We will use this term to understand the concept of series of real numbers. So for an infinite series an, we define Sn. What is Sn here? This is a sequence, you can see, and this is a series. Just see the symbolization. So I am representing S1 by the first term of the sequence. Now I added first two terms of the sequence. I represented it by S2. Now I'll add first three sums of the sequence and I'll add it represented by S3. And similarly, I'll add first n terms of the sequence and I'll represent it by Sn. So you can see what are these? These are sum of numbers, but they are not adding all the members of the sequence. They are adding partial. So that's why it is called partial sum. Partial sum of any sequence. So this is called sequence of partial sums. It is represented like this and it is called the sequence of partial sums of the series. Now, what are convergent, divergent and oscillatory series? So first of all, let's discuss about what are convergent series and there's some of their properties, basic properties. So if you have a series an representing by this, we will call it that this series is convergent. When we will call this, if this Sn, what is this? This is the partial sum of the series an. If this is convergent, so if Sn is convergent, then I will say that the series an is convergent. Okay, easy step. Now if the sequence of this partial sum, the limit of this sequence is S, or I can say it converges to S. So what is this S, capital S? This is the sum of the series. This will be called the sum of series, and we can represent it like this, that the sum of the whole series is equals to n. Now if the series converges, I am saying that there is a series which converges somewhere, then if you find the limit of the sequence, its terms sequence, you will find this, it will be converging to 0, limit n tends to infinity goes to 0. Now the converse of this need not true. What is the meaning of that? If the limit of some sequence is equals to 0 and you want to say that the series of n will be convergent, then this is not true. This may or may not be true. So this is the second thing. But what we can say about this, I am saying if a series is convergent, an is convergent. For every convergent series, I can say that limit of n tends to infinity, an equals to 0. Now, what if this is not equals to 0? So by the opposite term, I can say that this series will not be convergent. So the same thing is here. If the limit of this sequence is not equals to 0, then the series cannot be converted. So this is a method of checking the convergence of a series. This is one of the methods. Now, what are divergent series? A series an is said to be divergent if the sequence, sequence of partial sums of series is divergent. So what it is saying, Sn is divergent. Then what I will say? I will say that this series an is also divergent. What about oscillatory series? The same thing is there. If an is, this will be oscillatory here. An is said to be oscillatory if the sequence of partial sum is oscillatory. So if Sn is oscillatory, then this series an is also oscillatory. Now by these three rectangles, you can just see what is the relation between the sequence of partial sums and the series. If the partial sum is sequence of partial sum is convergent, the series is convergent. If the sequence of partial sum is divergent, it is divergent, and if this is oscillatory, the series is oscillatory. Now, what are telescopic series? So if you have a series A1, A2, A3, A4, A5, this is a sequence, let's say, and what you are doing, you are subtracting the nth element from its next elements. Subtracting an from an plus 1 means a1 minus a2, then a2 minus a3, then a3 minus a4. This will give us a new sequence. Now in next, this is represented by bn, let's say, and then we are representing a cn. What is cn? I am subtracting an plus 1 minus an. So an plus 1th term minus anth term. So what it means? a2 minus a1, comma a3 minus a2, comma a4 minus a3, and so on. Okay. Now these are two sequence, and I can also find, if I have a sequence, I can add its terms which will give me a series. So now if you have these series bn and series cn, they will be convergent if and only if, this is a if and only if condition, if the original sequence an is convergent. Now what I did, I took the, for bn I took the sequence of partial sums as n, and for cn I took the partial sum of partial sums as tn. So now the sn and tn, what are these? These are sequence of partial sums of series bn and series cn. Now they will be convergent if and only if the sequence an is convergent. So they are related. Now there are some tests for the checking of series is convergent or not. We have some tests for that. So one of those tests is Cauchy's general principle of convergence. What it says: a necessary and sufficient condition for a series an to converge is that for each epsilon greater than 0, for every very small number you want, you can take, there exists a positive integer m. You will have a positive integer m such that am plus 1 means you have an integer m, then the next term am plus 1th term plus the am plus 2th term next term plus dash anth term. You will add up all the terms, and that sum will also be less than equal to less than epsilon, for all n greater than equals to m. It will be always true for all n greater than equal to m. Now there is another method for checking the convergence of series. This is Springsheim's theorem. So what it says, if I have a series un of positive monotonic decreasing terms. Now this is important. It should be positive. All the terms of this series should be positive, and this should be monotonic decreasing. Monotonic decreasing means the next term should be it is an n plus 1. The next term an plus 1 should be less than or equal to an, then we will say it is monotonic decreasing. Okay, it is, we have a series. Now it will converge then not only un tends to 0. We discussed now, if you have a series an converges, this implies an limit of n tends to infinity an equals to 0. This we studied in the previous slides. Now it is saying if this is monopositive and second monotonic decreasing, then what will happen? This is all, then this is true, an will be equals to 0, but also n into an, limit of n tends to n, this will also be equal to 0 as n tends to infinity, and that's the same thing. So this is true only for positive and monotonically decreasing series. Okay, next. Now there are some terms, series of positive terms and series of negative terms. Till now we were discussing out the general series. The terms can be positive, the terms can be negative, the terms can be mixed, some positive and some negative. Now we will talk about series. First of all, in which have all the terms are positive, so it will be called series of positive terms. And then a series which have all the terms as negative, it will be called series of negative terms. So there are some special terms, there are some special series they are very easy and simple to discuss, to understand. That's why we are discussing them separately. There will be some different formulas, different methods, different tests to check their convergence or divergence. So let's see what are their positive terms or series of positive terms or negative terms. So if un is an infinite series of positive terms, first of all, it means all the terms of this series are positive. Then this Sn, what is Sn? This is the sequence of its partial sums. Then Sn will be always greater than the Sn minus 1. It means if I am adding a1 plus a2 plus a3, three terms, then it will be less than or equal to a1 plus a2 plus a3 and a4. This is S4. This is always greater than S3. So this is what they are saying. Sn minus 1, it always less than Sn. If it is a positive term sequence. So now next, this is the sequence Sn of partial sums of a series of positive term is monotonically increasing. So if you are finding this for a positive term series, S1, S2, the sum of partial series sequence of partial sums, S3. So what it will be? This will be always monotonically increasing sequence. Now next, positive term series can either converge or diverge to plus infinity. Now this is important. Either it will converge or it will go to positive infinity. What it means? It can't go to negative infinity. It can't diverge to negative infinity. Other thing, it can never oscillate if it is a sequence of series of positive terms. Two things. Now a positive term converges if and only if the sequence of its partial sum is bounded above. So what is the condition for its convergence? It will converge only if the sequence of partial sums is bounded above, because it is increasing, monotonically increasing. So if it is bounded above, so it will converge if and only if. Now this was the talking about the series of positive terms. Now we will talk about the series of negative terms. They say that sequence of partial sums of the series with negative terms is always monotonically decreasing, because all the terms are negative now. So whenever you will add a new term, so it will subtract something from the total. So keep decreasing, decreasing, decreasing. So that's why it is monotonically decreasing, always decreasing. Now the series with negative terms converges if the sequence of its partial sum is bounded below. In the positive term, it should be bounded above because it was going monotonically increasing. Here it is monotonically decreasing, so the partial sum should be bounded below. Okay. The series of negative terms can either converge or it diverge to minus infinity, because it is negative terms, so they will either converge or they will diverge to negative infinity. What it says, it also says it can't diverge to positive infinity. And second thing, it can never be oscillating series. So this was all the things which we discussed today about the series of real numbers. And you can see all our previous videos about the sequence, the concept topology, and all other videos on this real analysis playlist on the channel. You can join. If you have any problem, you can discuss your problems in the Telegram group. The link is again in the description. You can like, comment, and subscribe. Just if you like the videos, you can share it with your friends, those who are doing masters or graduation in mathematics. So this is done for today's class. Thank you very much for joining the class. Bye bye. Tata.